Looking to improve your web application security? Probly is reinventing web application security. Probly focuses on the vulnerabilities that matter, eliminates false positives with evidence-based scanning, and provides a simple point-and-shoot solution that is easy to use. Probly's thorough coverage ensures accurate identification of vulnerabilities in any modern web application or API. Improve your web application security processes by visiting securityweekly.com/Probly and start your free trial today. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Software supply chain attacks are continuing to expose vulnerabilities in organizations around the world. The time has come to focus your efforts on security for your software packages. Cloudsmith is the only cloud-native software package management solution for your enterprise. With Cloudsmith Continuous Packaging, you can securely deliver software across the globe and mitigate potential threats from entering your supply chain. With over 23+ formats supported, Cloudsmith is the solution that engineers choose to safely deliver all of their assets. Reduce unneeded downtime and deliver with confidence. Start securing your software supply chain today by visiting securityweekly.com/Cloudsmith.
Welcome back to Application Security Weekly. We have such sights to show you. I'm your host, Mike Shima, joined by John Kinsella. A couple announcements. Security Weekly Unlocked will be held in person this December 5th through 7th at the Hilton Lake Buena Vista. We'll have keynotes from Alyssa Miller, John Strand, Leslie Carhart, and Dave Kennedy. Visit securityweekly.com/unlocked to register now and check out more of the exciting lineup. You can also join us for our next live webcast on November 4th to learn about pragmatic steps to reduce your software supply chain risk. Then join us November 11th to learn the key insights and takeaways from the 2021 OWASP Top 10. Visit securityweekly.com/webcasts to save your seat. And don't forget to check out our library of on-demand webcasts and technical trainings at securityweekly.com/on-demand. This brings us to the news segment, but John, I've got good news and bad news for you. The good news is that I wanted to start off talking about a haunted code base and what makes a code base haunted. The bad news for you, unfortunately, is that we only have 30 minutes to do so. So let me steal a line from Scream and say, what's your favorite scary code base and why?
I'm probably still bound by NDAs. So for the listeners, Mike mentioned this to me on a Saturday or Sunday. I can't remember which day. He's like, in case you want to do any prep. I'm like, this is a topic I don't need to do any prep on. And we've probably had some of these rants over the years on this show. Let's see, what's worse for me? I'd say number one, if I had to put anything on, no matter what tools you have, we're talking about tools the sheesh last half hour. Numero uno is just a code base that I can't navigate, or that actually requires really heavy amounts of energy just to understand what the hell is going on. That has horrible, really unreadable at the end of the day. But by that I mean horrible use of variable naming, duplicated code. Like the same functions in different classes, and then someone originally copy and pasted it, and then one version would get changed and the other version didn't. Code where you're like, wait, I thought this was being handled by one part of the application, it's being handled by another part. Dead code that hasn't been removed. Really just an application where people at the end of the day don't care. I think it's really what it's one of two things. Either someone's super busy and they just try and get code done, go, or they don't care, or someone didn't care for them to go and clean it up. And that the result of that is it takes a super long time to get up to speed. You never really feel if you're up to speed with that code base. You're constantly worrying about where the vulnerabilities is, not if there's vulnerabilities, because when the code's that bad, there's vulnerabilities. So I'll start with that. How about there?
No, I think that's a great start, and it actually aligns quite a bit with my top, which is, again, sort of that idea of you've got to-dos and fix-me's scattered throughout the comments. And the other thing that worries me is when the code comment doesn't match the function implementation. So now you've got some really confusing things here. And it's funny that you pointed out basically readability, because neither of us so far have mentioned any specific programming language. And I don't think we need to mention a specific programming language to have a haunted code base for the very reasons that you and I just pointed out. That's a universal failing, so to speak, of poorly maintained code or code developed under lots of constraints, challenges of time, and et cetera.
And I think if you think about, I was going to make a Go comment. Last half hour, you were talking about you made a comment in there somewhere around how the code is formatted, and you wanted a linter to be able to make sure it's formatted cleanly. That's why I like Go. That's there. It's done. So there's one way that the code should look. That's it. But take a step back from there and think about JavaScript or other untyped languages. And I think part of the reason we have a problem with them, obviously, is there's a security implication. But the security implication is partially because either we, when we're reading or writing, we don't have 100% solid understanding of what is going to go through that variable we're using. So it's still, a lot of this comes back to the human aspect. It's not so much, the tools are really there. They're tools to help us. We can do the code review manually. We can do the penetration test. Well, penetration test is manual. We can do the dynamic web application testing manually or automatic. We can do linting manually if we really want to, but the tools are there to help us. We could compile the code down to machine language, but let's be realistic, right? So that's what these things are there. They're really just to help us with things that us humans have problems with. Not that they're going to have, sometimes they have magical qualities for someone who's new and they don't know how to find SQLi or cross-site scripting or what have you. But in many cases, they should be crutches in a good way. And that's sort of where we're here talking about how do I, get my legs stronger so I don't need the crutch, I guess, if I can really try to follow on that analogy. I probably shouldn't, but yeah.
No, I like that. And I think for me, the way I'd express what you were talking about with like the lack of typing, the typing gives us as humans, as developers trying to write code and read code, that those context hints. So I can figure out, what should this variable be doing? Because you also pointed out, poor variable naming can be really, really confusing, really difficult, and it gets hard to mentally build that mental model of tracking. Okay, here's the source of this variable. Has it been tainted? What's gone into it? Here's a sink. And I'm using the terminology of SAST as a callback to our last episode, but that terminology is really just those mental exercises we have to go through about what exactly is this variable and this function argument supposed to do. Should it have some ... slashes in it or some SQL injection or cross-site scripting? And when we don't have those typing, we lose some of that context perhaps. And that's where perhaps we also need to lean into better commented or possibly just better expressed, better written code. And I'm going to use that, and we'll come back to some of these scary and haunted code base ideas throughout this segment, but I think this is a good way for us to talk about some JavaScript, since that's what you mentioned. We've got two articles here. One about, let's talk about one that you targeted, or that you came across, about request smuggling vulns in Node.js. And request smuggling, something that was pretty big deal in 2020 from our James over at Portswigger, finding this in modern applications. Also then finding them in 2021 about mismatches in HTTP 1, HTTP 2 protocols, and now some more research in Node.js. So what was the interesting thing that stood out to you in this particular Node.js and request smuggling here, John?
So two things here. One was and we're going to talk about through some of our other stories, but I'm trying to get more. Well, I am hands-on day-to-day basis. I'm writing code almost every day right now, but I'm trying to get more hands-on with these stories from the point of view of when I see something come across that's interesting. Okay, and you guys have been hearing me do this. Can I dig into the patch? Can I see how they fixed it? What did they fix? What did it look like? Was it a simple fix, more complex? And in this case, it looks like Node has a private repo for security. So that makes sense, right? The actual pull request, I can't see it was on a private repo, and then they've got the patches public. But what was interesting as I went through this and looking at it, I'm seeing the unit tests to fix it, I'm seeing, and it's the first link on the news article. I'll paste into Discord in a second. Well, let me paste in Discord first, and people can read along if they're in there. Try and get better at that. But as you go through the actual code, you're not seeing any fix. And I'm like, that's sort of weird. How did they fix this? And then I realized that the fix is actually in a dependency. So what they did here is they started using a package called LHTTP. Which has got a lot of I guess Node used to earlier use another web library, HTTP library for doing the actual serving and stuff. And they realized at some point, hey, this is going to be, it's slowing down our ability to develop and, scale and do great things. So let's actually bring that in as a separate project or carve that out as a separate project and do there. And that's what the fix was. So it was sort of interesting from that point of view that while there's a patch in Node, frequently with these type of things, when something gets patched, and how we see it, we talk about dependencies every week, the fix isn't necessarily always in your own code, right? And it took me a second to actually realize that, because when I saw, update to LHTTP 2.1.4, that didn't mean nothing to me because I ain't a Node developer. So it's interesting to sort of see how some of these things go through and how you actually go about finding them and understanding what's going on.
Very much so, and I think that helps build the case for the benefit of diving into SCA as one of your early tooling approaches that Ashish was talking about in the previous segment too. And to me, the thing that was just kind of I'll use my Picard facepalm scale here, is that it's just that it's always interesting to see how is HTTP text off the wire being parsed. And this was pretty simple, not even necessarily subtle problems of just a space colon or a CRLF instead of just a line feed, and just watching how those implementation mismatches cause lots of problems. And so that's why we can have a standard, so to speak, of HTTP 1.1, but still have a little bit of, unfortunately, actually, I should say a lot of ambiguity in its implementation. And that's where lots of interesting security problems come from. And hopefully, fingers crossed, HTTP 2 is actually quite a bit more strict, I should say, about how to parse the protocol. And I think HTTP 3 is even more so. And those are all, I think, very good trajectories of how we'll get more, at least from the parsing perspective and the mismatches between this proxy versus this other proxy of these types of vulnerabilities. So fingers crossed, remains to be seen how much is my wishful thinking versus how much it might come out in reality. Speaking of wishful thinking, I wish we didn't have to, always look at NPM package vulnerabilities, because here's yet another one in a UAParser.js package. And this one, once again, we're in the JavaScript world still, and someone had basically Trojaned or had compromised the repo owner's account, so most likely through phishing. So they obtained the repo owners for UAParser.js. They got their credentials. With credentials, they made a commit. And so this is a very classic supply chain / dependency type of problem. And with that commit, they installed essentially a crypto mining, it looks like. And what was some interesting things that a good friend of ours, Adrian Sanabria, one of our Security Weekly host family, he was pointing out that there was a little bit of credential stealing that was being done by this, and that the specifically compromised the package manager for this and targeting the CI/CD pipeline systems essentially, rather than trying to use this as to inject some potentially malicious JavaScript that might be served to the client base through this particular JavaScript library. So that was kind of interesting how it was being done, but that's a long way of saying that, yep, once again, here's just another example of an NPM package. It was backdoored. But for me, I come around to, do we actually need, or how useful is it? Should we be having this, user agent parsing code in the first place? How much do we really need this additional attack surface versus just saying we're going to do a what's the better term of art? Feature detection or capability check within our code, rather than just saying, yep, this is how we parse the fancy string of a user agent header. So that's sort of where my mind goes, is just in the sense of there's so much code out there. Do we really need to be bringing all of it into our systems?
Yeah, there has to be a A cleaner way. I mean, we know. I was looking at this a few years ago at Learn Insight. We know at some point what's in the final binary or in the final, how shall I say, compiled to target, whether that's live compiled for Node or Go or pick your poison. At some point, that usually goes through some sort of a compiler or a parser to figure out what's actually being used. It'd be very nice if we could get that to happen earlier in the code chain, build chain, to be able to actually get a better understanding. Not just, we're importing these 300 Node libraries, but what are we actually using in there? Thanks for posting that in Discord. And I think that's, we were just talking about tools and communication. Actually, both these stories we've just talked through, you have to have a tool, right, to actually understand all the SCA you've got when you do like a single line of an include in or an import, in JavaScript, ends up with this big crazy pile of stuff that you've got suddenly in your code. And then the second part of that is how do you communicate? How would either a developer communicate to people when you import my code, this is all stuff you're bringing along, or maybe, hey, if you don't want to have all that baggage, here's a lighter weight version of the library, or what could you do there? There are different things. So these things that go bump in the night are all sort of part of this process. And it's sort of funny, we're not doing this purposely, but so this article is on the record, and you're talking about Adrian, and Adrian had Adam Janowski from, he's the editor over at the record. He was on ASW last week, so funny how these things all come together.
No, indeed. I think the one other thing I want to add to this article that you reminded me about is that there's also a question here of, were we affected? So let's say that we know that UAParser.js is present throughout our code base, but how can we answer the question of, did we download that particular vulnerable version? And this is where either SCA can help, or just a general, call it, asset inventory of your dependencies. How easily can you go through all of the code that has ever touched a developer system, or more importantly, even a production system, or your CI/CD pipeline in this case, I should say, and can you enumerate down to the idea that, okay, these are the names of the packages, but even better, these are the specific package versions at these times. So we can say, this was our window of exposure on this particular date for just 1 hour or maybe 8 hours, or we actually weren't exposed at all because while we use this package, we jumped from this version to this other patched version just through our normal update process, and therefore we didn't pull it down. And those, I think, are some other good things to focus on, just in that basic principles of what kind of observability do you have into the packages that are being used, setting aside even just the security aspect of it.
Yep. Let me rabbit hole on that one for a second, because it's really interesting. So not JavaScript, not even a security issue, but so Amazon at some point I want to say the beginning of this year, beginning of 2021, they came out with a version 2 of their SDK for Go for Amazon. So this is, the library that I use when I want to communicate with the AWS stuff. Version 1 was around for the last, I guess, probably close to 10 years. I'm not sure when it came out, but let's call it 10 years. Call it 5. If you go out looking for how to do something for Amazon and Go, 99% of the links you're going to get are going to version 1, or articles or blog posts talking about version 1. Amazon still has their version 1 code around. It's still in their blogs. It's still in their examples. It's still everywhere. So actually, just getting the examples for version 2, enough stuff has changed that it's actually sort of painful. And then on Friday, I decided, hey, let's move over to version 2 completely. Let's get V1 out. I remove it from my vendor path and go. And all of a sudden, things started breaking. And it turns out a few of the other tools which I was using for either secret management or connecting to a database or different things were still using the version 1 code. So I'd go back through those open source projects and start looking to see, okay, is there even like an issue open to work on V2? I didn't think I saw one across 3 fairly decent sized projects. So now I'm stuck with having a version 1, version 2 of my code. And I know that's going to bloat the binary. I mean, I don't care about that too much. I care about compute maybe, but not the binary size. But that's sort of part of the problem here, right? It's again, we're back to communication and back to thinking about how do we push this ahead? Do those open source projects even know there's a V2 out there that they need to think about supporting it? How, I suspect it's going to be at least 6 months until those guys are up to speed on it. So I could spend some time here and there and try to help out, and I will. But how do we, that's just one tiny, it's a big example of that, but that's just one example. If a large project like AWS, people aren't adopting the V2 after 10 months, how do we expect all these little guys, which are getting included down the path in a node import, to be updated or managed?
Well, I'm glad you mentioned that, because speaking of code from 5 or 6 years ago, we have another article about Squirrel Lang, which I had to bring in just because the name of the language itself. But also it does tie into a little bit of the theme of gaming and sort of threat models, and just kind of looking at what are the different threat models in different industries, still related to AppSec, but within games. In this case, some researchers found in Squirrel Lang, which is basically a Lua-like or Lua-esque type of scripting language that's used basically to create mods and maps for, in this case, Counter-Strike Global Offensive. But within it, these researchers identified how to create basically a null dereference, get an out of bounds read vulnerability, and boom, they could break out of the sandbox that this is designed to contain. I'm losing my brain. Designed to contain the code. The reason for using something like this scripting language is that you'd want to have a couple properties. You want to have something that's relatively accessible to your gamers, to your players. So that's why you don't necessarily want to go into the C++ direction of a language to use. And the other thing is that if you can also create a language that's relatively self-contained, you can also build some better security properties around it. Hence, something like Lua, which is actually pretty desirable, has those desirable properties, because you want to be able to understand how the objects, how the data is interacting with itself, to avoid situations like this that can break out of a sandbox and then jump out of the game code, if you will, into the system level, and then bad things could potentially happen through malware, through a backdoored or a malicious modification. So that was kind of the setting up aspect. But the big thing here that stood out was that clearly there's an appeal to the game developers to use something like this. But if you look at the Squirrel Lang site, the last stable version was released back in March 2016. So that's not necessarily to imply that old equals insecure, but it at least, I think, strongly implies, if not explicitly so, that the maintenance of security is lacking in this case, clearly, but also it's not necessarily being kept up to date with new design principles, new benefits that may come from even just fuzzing or even just simpler additional compiler settings to building this sandbox. So you can check for a lot of the LLVM, undefined behavior sanitizers, address sanitizers, these types of things that can just help identify problems within code. So my long-winded approach here is just the idea of this is a haunted code base because it's old and it's relying on older tools and hasn't necessarily been well maintained, and yet it comes out into modern games. So this is what unfortunately happens when you bring in these types of haunted code bases. And I think I've beaten that one to death. Not sure if there's anything else you might want to add onto that one, John.
Not much, unfortunately, just haha funnies. Once you mentioned the fuzzing, there has to be some sort of connection between squirrels and fuzzing, right? Like you have to have like a fuzzy squirrel or some sort of, these guys have to do something there. Yeah, it is, as my noise sort of gave hint there, last commit 2016. And it seems like there's 61 open issues. Are any actually being responded to? Because that's interesting, right? So people are opening issues. Looks like they're getting a little bit of response, but still no changes to the code itself. I mean, the next thing is sort of go check, is there another branch that they're working on? No, only a single branch. So yeah, 18 open pull requests. So these are sort of the way I go through when I'm looking at an open source project, which I've never seen before, because I heard of this last week, but I didn't look at it closely. So open pull requests since 2016, 2017, 18. So basically that I would consider that an maintained project, unfortunately. We see a lot of this on GitHub. I've been seeing a lot more recently where someone will just leave something there. I appreciate the memes in Discord. But yeah, it's, again, so I think this is going to be a growing problem that I think at some point GitHub's going to have to possibly do something about it. I mean, they added, in the last year or two, they've added the ability to mark your project as archived, I think it is. But really, like, okay, you've got something like this. This hasn't been used. Or excuse me, it hasn't been really seriously updated. I get it. People are busy. They lose interest. Funny, haha, squirrel thing stop being funny when, you keep getting bugs or you got other things in life to do. I get it. But at that point, how do you either let someone else take it over and make sure the right people take it over? Because that's the big thing, right? It's very easy for someone to raise their hand and say, I'll help maintain this, but do they actually do it? That's what we see in open source. They frequently don't. Again, good intentions. But how do you get this thing going and keep it alive and get it into right people's hands and then let people downstream, like those game developers in this example, know, hey, by the way, that thing you're using that everyone uses, I don't know who uses it, but they, capital T on they. How do we get them to sort of be up to speed, or maybe possibly get them to invest a little in this to keep this thing up to date? So that's sort of it's a growing problem, I think this is, and we'll see how it goes over the next few years. But it's a good example.
Yeah, and that last point hits that. How do you go through that decision, the engineering choice of, do we fork this and create our own, and now we've got Mecha Squirrel next to Squirrel, or do we just figure out, it can be community owned, and we'll try to get some activity on keeping it maintained to exorcise the bugs out of it. I've got a couple other vulns, or one other vuln that I did, or article about a vuln about SQL injection, was just more of a bit of trivia about using a scientific notation to bypass simpler types of alerting, simpler type of WAF rules. Now, there's nothing, not to take away from the fun of it, but it's not like there's a new vulnerability out there. You still actually have to have a SQL injection vulnerability in this day and age for this neat scientific notation technique to work. But I thought it was kind of a bit of fun trivia. But I'm going to so I want to mention it, but skip over it quickly and start to switch from a lot of the vulnerabilities we're talking about into, I think, the other group of articles that we've gotten here. One about some videos about education. We can kind of save those for the end. But John, you were grabbing some things about professional developers, about who should be doing or who could be doing development and security. And I also grabbed an article about just a blueprint for securing software development that's a little bit more on kind of the CI/CD side of things. But let's go. So I think there's a combination there. Or let's start with what you were looking at, something from Gartner, of all things.
Let's see how we can put it together. So article we got on VentureBeat, but underlying is from Jason Wong over at Gartner. And I mean, it's a very catchy phrase. I don't know if you used it. I didn't watch the symposium this year. IT symposium, I think. I'm not sure if it's online. It's probably just pay only. But Gartner IT symposium, it's a pretty decent day of thinking if you can get into a show like that. It might be for customers only. I can't remember. But anyways, the phrase here which catches our eye, citizen developers. Ooh, what's that? Sounds like Citizen Kane or Citizen, all sorts of strange references around Citizen itself. But what they're really trying to post here is the idea that between no code and low code, us professional software developers, to wear that hat for a second, are going to be outnumbered 4-1 by the year. Do we have a year in here? I thought I saw one earlier. I don't. Yeah, they're 2023. 4-1 people who think they know how to code using Excel or things like that, versus the actual software developers who, they've got some level of education and professionalism in this. I won't say that they've got a degree, because many don't, or even went to school for that. But anyways, the point being, that's interesting. But now that we've gone there, now that we've got this, we're in the minority, and as I snarkily say in the wiki entry, sort of the way the security people have felt compared to professional software developers for the last 10 years. But now that the professional coders are in the minority, along with the security people, how do we provide some level of assurance of the maturity and the upkeep of our software? So by that I mean either it could be security, it could just be, if code is being generated, it might be great if something is being generated by a no-code system. More likely it won't be, right? But it might be really great code. But how do we make sure that meets the standards which we are striving for in the rest of our application, the rest of our business? And I think that's going to be an interesting thing to think about. That was really sort of, I took the headline and sort of some of the points they were saying here, and then sort of went off and left field in my own sort of brain, which unfortunately does that sometimes. But I think that in this case is interesting. How do we know, is that code secure? Is there SQLi in there? Do we have to start doing a SAST on third-party code, which is being generated by some sort of tool like this? What do we do? And I think that's something for us to keep our eyes on.
Indeed, The Brain of John Kinsella, another horror movie coming this fall. It also makes me think too is that to kind of tie it in actually to Node.js of all things, is that in a lot of these cases the underlying code it all comes down to a lot of times C or C++ as well. So especially like Node. Now, personally, putting Node and JavaScript on the server side isn't going to be in my top list of things that I want to do, but it's getting into using like that Chrome engine, and this is where we can say JavaScript and being able to do a lot of parallel programming with it, or things like that, or easy threading, if you will. You still need that sandbox and that VM that's in C++ to be well fuzzed, to be well handled. And we've seen 0 days several throughout this year in Chrome. So there's still these problems. And I guess I'm just kind of, I'm agreeing with you and making the case for examples of how we've seen these types of abstractions into JavaScript or languages like Squirrel or the no-code, low-code that you're describing still boil down to an underlying foundation of C or C++. And maybe that's the foundation we also want to get away from. This is where we should perhaps be talking about Go, Rust, more memory safe, more languages that are just more friendly to read and understand, as well as to instrument from a security perspective. So that's what I'm going to tie in your article there, as well as some of the controls that this other article about just how do you add some tools, or how do you create a blueprint for a software development pipeline.
Someone in Discord just mentioned a phrase I really like: armchair software development engineers. So I might have to start using that one going forward. That has a nice ring to it.
As long as, and I'm sure to be fair, I'm sure we also have quite a bit of armchair AppSec practitioners as well. And the reason I'm being harsh on that is because still to this day and age, we're still dealing with cross-site scripting and SQL injection. So challenge to the industry, let's kill those vulnerability classes in a much better way that leaves them dead. So then we exit the metaphors of Halloween and things rising from the grave, that we've sprinkled our holy water and put a stake through the heart, and those evil creatures can stay down. But I think we're coming up to the end here, John, and I'm running out of good spooky metaphors. One other thing I'll mention real quick: Loftcrack is open source. Password, very ancient and important to the history of AppSec, if you will. Although I don't know that password brute forcing, password cracking is really that relevant in modern, in modern AppSec. There's so many other vulnerabilities that you don't need those password hashes necessarily. Still has a good niche environment for niche uses, but I'm just not too excited about it as a modern tool, but definitely want to acknowledge the history, especially what Loft has done, as well as a lot of the members of Loft have done to create companies that are still around today helping the InfoSec industry. So I wanted to hit that, and maybe we could end on when your vulnerability isn't enough, that crowdsourcing your exploit, the article that you picked up, John.
Yeah. Loft heavy industries. Yeah, it was cool to see them come out with that. I wish they had the whole commit history in there. Maybe they didn't. There's only like 4 commits in the repo. And then it's C++, so I quickly lost interest. But yeah, so this one I thought, again, I guess I'm doing a lot of the deep thinking thing this week. So this is about a vulnerability which was found in WebKit on PlayStation 4 firmware. There's something in font face, which I believe there's a use after free in there. I'm guessing around either the name of the font itself or some of the details around the font. When sent through a web page, it's somehow being used after free, which means if you know what you're doing, you can throw some extra code in there and possibly get some code execution on a font name. So when I was originally looking at this, the original reason I wanted to bring it in was just thinking about targeting. Like when someone is actively looking for a vulnerability for a target, like an ODA, Am I going after a CEO of a company, or like maybe like what a senior security person to try and get them, fish them, get them to do something so I can get into their system and get access internally within that company? Or that's more targeted attack? Or am I looking to do something that I can run on, I don't know, a few million systems and do some Bitcoin mining like on a PlayStation 4? So that's where I originally was coming at this from. And then when I was looking at it, you realize that, okay, he doesn't actually have this yet. And what he's actually doing, he's got a POC for the exploit, but really what he's doing is, hey, asking a bunch of people, can you go and run this and see if it runs right on your PlayStation? And it's basically large scale QA, right? And I thought that was a more interesting way to go with this. Is we've talked about this a few times, I think, but in part of the reason when I'm doing these follow along and look at the patches and stuff, when you hear me go into these open source projects, I'm trying to get some of our listeners to go down that path and sort of explore and poke and prod and see how this stuff works. And I don't think we've done it too much on actual exploitation, which I've done for various reasons, demos being the more common one. As someone in security vendors, we always have to show that either, hey, here's a vulnerability which is out there which my software can stop, or here's a vulnerability that we found, bad, you need our software, one of the two. But that stuff is almost never as simple as it seems like, right? When I was doing the container security stuff, run C vulnerabilities are out, you'd basically feel like you'd have to be like standing on one leg and like holding a hand up and like tilt your head just right to get the vulnerability to actually execute. Right. You need the right version of run C, Docker, blah, 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 right? Linux kernel, all these things have to be right in line to stars. So I think that's, I think as a good note to end on, this is a non-scary, this is a really sort of happy fuzzy note for people to think about. A lot of these vulnerabilities that are out there are definitely very easy to compromise, or it's very easy to attack you once someone's actually gone through what he's doing now and figures out a stable exploit and then weaponizes it and turns it into either a rootkit or some sort of malware. Excuse me. I've got a squirrel in my throat. But in this particular case, he hasn't got there. And I think that's worth people thinking about and thinking through, okay, how do I, if you are trying to do this stuff at home and it's not that easy, it's not just you. It's frequently these things take, like I said, the right amount of stars getting aligned to be able to do this type of things. But then once you have it, maybe that's not going to run on your friend's machine, or if you're doing it in a VM, if you reboot the VM, or all these type of things. So there's a little bit of light at the end of the tunnel is sort of the end statement on some of these type of things. So that's it. I thought it's a good thinker, a good one to sort of think through, look at what he's doing. The underlying technology of the exploit is modern and current, and something we should be paying attention to. We've been talking about like parsing and fonts and rendering and all these type of things, but also that's nice. It's academic what you actually do with it. And if you're going to go tell your boss, hey, there's a vulnerability out there, we need to start patching, boss man sometimes going to come back and say, or boss woman, come back and say, that's great. Can we actually exploit it through this? If they do exploit it, what are they going to get? So good little homework assignment for folks listening. How about that?
Yeah, a great threat modeling homework from John. Thank you. I think that's a great way to end it now. And I also want to end by saying thank you, John, for helping us once again through the news segment and talking with Ashish. I want to thank everybody who was in the Discord channel joining and chatting along with us as we're doing this live. I also want to thank all of you for joining us for these Haunted October episodes. Do please take a moment to like and subscribe to the podcast, grab a FIDO key for your MFA, and check for monsters under the bed one last time, because we want to see you again next week on Application Security Weekly.